In this video, I want to talk about one of the forms of reduced inrush motor starting called part winding. Inrush current is the initial current draw when the motor is first powered. That inrush current can be up to 300 to 800% of the full load amps of the motor if you're starting it across the line, which means putting full voltage on the motor from the start. Part winding start reduces the inrush current by 25 to 40% and is designed to reduce the voltage drop that you initially see when the compressor first starts. On the Copeland 4R to 8D type compressors, you'll see this is the wiring configurations based on 230 volt or the 460 volt across the line. Looks exactly like you would see on a 9-lead Y type motor, where if you're powering 1 and 7, 2 and 8, 3 and 9, and you have the jumper between 4, 5, and 6, you put 230 volt, 208 to 230 volt, and it starts across the line, which means full voltage right off the start. And for the 460, you power 1, 2, and 3, and you put the jumper between 7, 4, 8, and 5, 9, and 6. The option here in the center is part winding. That means you're going to use two separate contactors to do basically what you did here, but you're going to power 1, 2, 3 independently of powering terminals 7, 8, and 9. It looks like this. You have a contactor that feeds terminals 7, 8, 9, a separate contactor that feeds terminals 1, 2, and 3, and that's pretty typical for Copeland. And here's a Carrier Carlisle, the 06D, 06E semi-hermetic compressors, a typical diagram for them. Anytime you see a Carrier unit that has a 6-pole breaker, there's a pretty good chance that you're looking at this configuration. There's the 6-pole breaker, and it's split out to two separate contactors. Again, contactor A1, CA1 would pull in first, and then CA1A would pull in, and that would energize the second half of the windings. How that's controlled in the Carrier diagram that you see here, I'll expand it to see the highlighted part there. You see here's contactor A1 and contactor A1A. That would be the first half of the windings. This would be the second half of the motor windings. And between those two is this 1 second part winding time delay. As soon as you get power on CA1, it energizes the motor leads 1, 2, and 3. 1 second later, CA1A pulls in and it energizes the windings from 7, 8, and 9. This contactor is used for across the line, is what the note here, and for part winding. If for some reason you energized, you started the compressor and CA1 pulled in, but A1A did not pull in, it would probably trip the breaker because it's drawing too much current. If this 1 second time delay goes bad, that could cause that to happen, and you could temporarily just bypass the time delay as if you were doing the across the line start, just to prove that if both contactors pulled in, the motor would start and run. This time delay is a part that you don't want to ever have fail, but if it does, you need to recognize that that could cause the compressor to trip the breaker.